Hey, you. Get back in here. Get back in here. You have not wandered into the wrong class. I know somebody out there is wondering why are we talking about DHCP in a CCNP switch course, and or why are we talking about DHCP in the middle of the security section. Well, there are a couple of good reasons for that. First off, DHCP questions are going to be on your CCNP switch exam, and they're liable to show up on your T-Shoot exam as well. And you have to know what's going on with DHCP in order to secure it, which we're going to do a little bit later in the course. I'm also going to make it worth your while with a new lab that I've never done in a CCNP course before, that I'm tired of some of the, not misinformation, but some of the left out information about a certain DHCP feature. So you're going to see that in action live here on the live equipment. But first, we are going over some of the fundamentals. And you know the basic process, but it may have been a couple of years if you got your NA years ago. It might have been a while since you've seen it, so we need to make sure this is fresh in our minds. So it's one of those things that works so well, DHCP that is, that we really don't pay it a lot of mind, and then all of a sudden you get asked picky little questions about it. It's like, I don't remember that. Well, this is going to fix it so you do remember that. Now, the client gets the whole ball rolling with DHCP by sending a DHCP Discover packet. And I hate to insult your intelligence by telling you what the purpose of that packet is, but it is to discover the available DHCP servers. This packet is a broadcast. The DHCP servers that receive that Discover packet are going to respond with an offer packet. Now, this is also a broadcast packet, and it includes an IP address the client can use, along with notification on how long the client can keep the address, which is the lease, of course. It gives them a default gateway and other info as desired and configured by you and I, the network admins. Now, many of these offers are indeed offers that can be refused because the client is really not picky about the DHCP offer it's going to accept. It accepts the first one it receives. Now, the client uses another broadcast message, a DHCP request message, to indicate acceptance of that offer. The request includes the IP address of the DHCP server whose address offer is being accepted. Now, this is broadcast because you want the other DHCP servers to see it. And when a server sees a request that doesn't include its own IP address, it says, oh, okay, that offer I sent out was not accepted, so I'm withdrawing it, and I'll put that address back in the pool. Then finally, the DHCP server whose offer is being accepted sends a DHCP ACK message back to the client, and that's really the end of the process. Now, this ACK can be a unicast or a broadcast, depending on the circumstances. This isn't something you're going to need to get into for your NP exam, but I would hear that all the time with the NA. You know, it's like, well, is it a unicast? Is it a broadcast? You know, what? Under some circumstances, it's a unicast, some it's a broadcast, so technically everyone is right, and we're just going to leave it right there. Now, generally speaking, of course, you're going to have a traditional server, traditional box for your DHCP server. But a Cisco router or multi-layer switch can really handle that role nicely. Now, the syntax, as always, takes a little bit of getting used to. But like anything with Cisco, you know, take it one command at a time, one concept at a time, and you'll be more than fine. What we're actually going to do is have a Cisco router acquire an IP address via DHCP from a Cisco multi-layer switch. So we're going to do some of this live too as well. And here's the setup. The client is going to need an address for its fast Ethernet 0/0 interface. And that router, is connected to the multi-layer switch at fast Ethernet 0/2, which is going to act as a DHCP server. And it's got interface VLAN 4 on it. That's where we're going to put that host. And it's the IP address 10.111/24. Now, using a multi-layer switch as a DHCP server, there's one big requirement right away, and that is that it has to have an IP address on any subnet that it's offering addresses from. Makes perfect sense. Now, the only thing that could drive you a little nuts, and I still fall for this every once in a while myself, because this isn't something you can figure every day. When you exclude addresses from the pool, that is a global command. You are also going to have some DHCP pool commands. After we create the pool, we'll define a DNS server and a default gateway and the network, that kind of thing. But when you're excluding addresses, that is a global command. And the command is IP DHCP excluded address. And we're going to use that live here in just a moment. Now, we can specify a single address to be excluded, or an entire range of addresses, or both. And here, what we're going to do is assign addresses from 10.0.0.0/8 via DHCP, but what we don't want to do is use the addresses 10.0.0.0 through 10.1.1.0. We also don't want to assign the IP address already assigned to the SVI interface VLAN 4. Got to watch that. We don't want to give that one out. Now, IP DHCP excluded address will get the job done here on the screen in just a moment. Now, I do want to say in advance, I could have used one command with the range 10.0.0.0 through 10.1.1.1, but I want to illustrate two things to you here. First off, that you can use this command to exclude a single address, because I see this question asked a lot, and you'll see why, because of the syntax. And you can also use the command as many times as you need. So you don't have to go back and write one long statement. If later on you have other addresses you want to exclude, you just add them onto the list. So let's go ahead and bring the live equipment up here and point it over here. And let's go ahead and start our global configuration. And we've got quite a few DHCP global commands actually. The only ones we're working with are excluded address, and there may be in pool, which is configure DHCP address pools. That's how we go into pool configuration mode. But right now, we're going to work strictly with excluded address. And we're not going to concern ourselves with the VRF options we see in any of these commands. Just I'm not even going to discuss them. Just leave them out. That's something for the future. Right now, though, we're asked for low IP address. And that's where people get a little confused, because sometimes you just have an address you want to exclude. And I'll show you how to do that in just a moment. It's intuitive. But let's go ahead and put 10.0.0.0 for the start of that. And you just put the high IP address of the range next. And also notice that IP DHCP excluded address 10.0.0.0 was a legal command by itself, because we see the CR down there. And that's it. No other options. So there you go. Pigeons are not released. You're not going to get a whole lot of messages from that. Also, when you want to exclude just one single address, just put it there, right there in the low IP address, and leave the high IP address blank. And you're not going to get any warnings or anything like that. There's nothing illegal about what we just did. So there's our little config message. And now let's go ahead and jump into pool configuration mode. IP DHCP pool, you got to give your pool a name. We're going to call our CCNP, since that's what you'll be. And that's all there is to it. There are no options, and you always want to watch that null space. So you got to be careful with that one. Now let's go ahead and we're going to start with the network command. And network number in dotted decimal notation. It's kind of funny, it even tells us the dotted decimal part, but we'll go with 10.0.0.0. And here is a rare option. You actually get to use prefix notation if you want to. You can use the network mask or the prefix length, with it, whichever way you want to express it. I'm just going to go ahead and do a /8 right there. And that's it. Let's take a look at some of the other options here, because we're not going to look, don't panic. We are not going to look at every single one of these options, but I do want to call a couple of them to your attention. Starting at the top, let's see, we've got default router and DNS servers and domain name all right next to each other. And let's see what else. Host just might come into play later. Here's your network command. We just used that. We've got a relay option to function as a DHCP relay. All kinds of other options. But again, you're really getting into DHCP nuts and bolts when you get to that level. So we're going to stick with a couple of general commands. And that's going to be it for this part of the lab anyway. So, you just go ahead and set a domain name if you want, preferably with all the letters. And we'll just call it BryantAdvantage.com, because after all, I'm running it. DNS server, you can put the host name or the IP address there. Default router. That, of course, should be the IP address of your SVI in this case, which was 10.1.1.1. And that's it. Of course, you could put a backup there if you wanted, but we're not going to. We're just going for the one. And lease. Let's talk about lease for a moment. Now, of course, in DHCP speak, that means the client can keep the address for this long. So what are we going to do with a command that has at least one numeric value? iOS help. Absolutely. Definitely, this is the kind of thing you want to use iOS help with, because if you set this incorrectly, all of a sudden you're going to be saying, why am I getting so many new leases all the time? That kind of thing. It's not crippling or anything, but still you want to get this right. So if you want to set it for a year, you could set it to 365 days. It seems a tad extreme. Do note the infinite option. Jupiter and beyond the infinite, something like that. Anyway, and beyond the infinite. Never mind. So we've got infinite lease, and of course we could use that if we never want it to expire. But if we wanted to go for, say, a 7-day lease, a lot of companies do that, you can just hit enter right there, and it's going to be however many days you put in, and that's the end of it. But if you want to get a little more detailed about it, you could say 7 days and 12 hours from now, and 15 minutes, and that's it. It couldn't hurt to know the order of those, I think. Just a hunch. Could not hurt to know. Again, it's days, hours, minutes. And what 7, 12, 15 would mean, of course, is that you've got a 7-day, 12-hour, 15-minute lease. Generally, you're just going to go with a certain number of days, and that's going to be it. So we will just go with 7 right here and hit enter, and that is it. I want to show you 2 more global level commands with DHCP. And something on the board that goes with this, actually. Because we're going to come back. We've already done a lot of those. And we're going to come back to that. But this isn't something that you're going to adjust a lot. But when a Cisco router is acting as a DHCP server, it's going to check for IP address conflicts before assigning an address, which we appreciate. The conflict check takes the form of 2 pings that will be sent to that address that's about to be assigned. And those pings are going to time out in 500 milliseconds. Now, if they time out, we're good, and that address can be sent to the client. That's one time we actually like a timeout, because if we're pinging them and they don't answer, that means we can give out that address. If we get pings back, well, the check has failed and we can't assign that address. This is not a value that you're going to adjust terribly often, but if you want to change the number of pings sent during that check or the timeout duration during the conflict check, use the commands IPDHCP ping packets and IPDHCP ping timeout. If you set the number of ping packets to 0, that disables the conflict check. The router even tells you that, which is kind. Note, these are globally configured commands, and that's why I'm showing you these more than anything else. It's just another couple of commands you might want to know. IPDHCP and then ping. If you want to specify the number of ping packets, you just do it with that command, IPDHCP ping packets. If you do 0, you're basically you are fundamentally disabling that check. And then finally, if you want to go to timeout, you could set that 100 to 10,000 milliseconds. You cannot set that one to 0. Doubt you get that detailed on the NP switch, but I get asked about those once in a while, so I want to share those with you and also make sure you know they are globally configured commands. At the beginning of the very next video, we are going to go ahead and get started with getting an IP address onto that router interface via DHCP. And I will see you, and we'll take care of that on the very next video.